As you understand from the previous topics that we've discussed, by default, STA tools assume that all timing paths are to meet timing in one clock cycle when you have a single clock design. Now, there are paths that require more than one clock cycle, and such paths are called multi-cycle paths. Some multipliers are pipelined to one cycle, but when the output of the multiplier does not require pipelining, it must be considered a long path and a multi-cycle path must be defined through the path. The rest of the design must be considerate of this known long path and use its output only after certain cycles. Then it becomes a known multi-cycle path. For such multi-cycle paths, you don't want the synthesis tool to waste any resources, trying to figure out the best way to optimize this path to fit into one cycle. Therefore, you make an exception. You tell the tool that this is a known long path and that it is a multi-cycle path so that it can skip optimizing it for one clock cycle. In the setup example, on the left, we tell the optimization and timing tools that this path is a multi-cycle path and that it will require 2 cycles instead of 1 for the setup check to happen. You also need to tell the tools when you have a hold multi-cycle path. Here the clock path is longer than the data path. Therefore, in this example, you verify the hold not at the launch edge, but the edge before that. You can use the set multi-cycle path command to set multiple cycles for a particular path. As mentioned in the example shown, using a multi-cycle path also changes the hold check. For multiple clocks, most tools use the start and end cycles along with the set multi-cycle path command. To specify a setup only multi-cycle, the setup checks are always relative to the end